All right, hello. Welcome to the CoreOS webinar here today. I'm Alex Colby, the CEO of CoreOS, and with me I have Justin Dean from Ticketmaster. Justin, would you be willing to introduce yourself here?
Yeah, sure. So I'm Justin Dean. I lead our platform and technical operations here at Ticketmaster.
All right, great. Thanks for taking. Oh, go ahead. All right.
I was just going to say I've been in Ticketmaster 2.5 years or so. So yeah, I'm glad to be here.
All right, cool. Thanks for taking the time today to do this. We're looking forward to hearing about kind of everything that's been going on in your world. So here's what we're going to be talking about. We're going to be running through kind of the work that we've been doing together, some of the challenges that you've been seeing that you think aren't just common to your business, and then your specific journey, why you chose Kubernetes, and then why you ended up partnering with us. So does that all sound good?
Yeah.
All right, let's do it. So first, just a little bit about CoreOS. CoreOS, we've been one of the companies helping create this whole space around containers and distributed systems, really culminating around the work we've done with Kubernetes over the last 4 years, and building kind of all the central components to make this category possible. As a business, our product is Tectonic, which is an enterprise distribution of Kubernetes, and it's meant to help the world's largest companies adopt this technology. And then, overall, as a business, we help these companies with their journey, not just with software, but also with a variety of support, engineering, and educational services and training. And Ticketmaster has been working with us kind of across all these areas, contributors to Kubernetes, using Tectonic, as well as partnering with a lot of our team, from the engineering teams to even the marketing teams in cases like today. And so, again, thank you, Justin, for taking the time to do this. Justin, what is Ticketmaster all about, in case some people haven't heard about it for whatever reason? Maybe you could just briefly introduce Ticketmaster for us.
Sure. Yeah, most people know Ticketmaster, the website, or trying to buy tickets, but most people don't know the size and scale of Ticketmaster. So Ticketmaster was founded in 1976, which makes us a 41-year-old company, and we're currently operating as a startup, essentially. So we're re-energizing the company as a whole, which we'll talk about in a little bit. We partnered with Live Nation in 2010, so we became the world's largest live entertainment company. We do $8.35 billion in revenue as a company, and then we do $25 billion worth of gross transaction value on our platforms and systems that we build here at Ticketmaster, which puts us in the top 5 e-commerce website category.
That's awesome. Okay, and let's talk just a little bit about what was the state of technology at Ticketmaster before you began, containerization in Kubernetes.
Yeah, sure. So, just like any successful, mature business that's been around for a while, including decades, right? We've got the technology footprint to match. So we literally have every era of software, everything from 1970s custom VMX or VMS VAX software that we run, our ticketing nucleus, we'll call it, or the kernel of our ticketing engine, going all the way up until things that run in containers, things that run in public clouds, and then a huge section of the middle ground stuff where it's the 5 to 10-year-old type of private cloud infrastructure, your traditional VMs, massive Zen clouds, your NFS-backed storages at scale, right? The classic NetApp filer world. So we've got really an assortment of infrastructure to run the company on, which is probably pretty common for most large enterprises. We sometimes refer to it as our technology museum.
Great. Okay. And I mean, maybe you could just talk a little bit about, I guess you covered a lot of this, but, you know, kind of the overall footprint, you know, where you're at today.
Yeah, so the scale of Ticketmaster is pretty daunting, to say the least. So we have 21 full-blown ticketing system businesses that you probably wouldn't realize from the outside, but you know, there's ticketing platforms and businesses that either we've grown internally or whether have come from acquisitions over the years, but covering a lot of different segments of the market. You know, everything from concerts are different than sports, different than season tickets, different than DIY ticket hosting. So a lot of different products that we support. 1,400 people thereabouts in our product and technical organizations. You know, we have a large private cloud footprint with a couple tens of thousands of systems that it hosts. 7 data centers globally, plus our public cloud footprint, which is not mentioned here explicitly, but you know, we're Amazon customers, and you know, we have a pretty complex network setup to go along with it. So if you think about all of the venues and arenas and places where you scan a ticket, you know, we in some way, shape, or form have to connect into that network. And we're continuing to grow at scale. So the tech scale is definitely a huge challenge for us to keep up with at Ticketmaster.
Right. I mean, yeah, this is I mean, it's extremely sophisticated. I mean, a lot of infrastructure that you're dealing with for sure. So I guess what led you, what challenges led you to recognize that you overall had a problem that needed, you know, needed change?
Yeah, so there's a lot of challenges in our technical ecosystem, but I would say the one that is first and foremost the brightest light for us and anyone who works at Ticketmaster is our phenomenon called on sales. That is a huge portion of our business, right? And most people know Ticketmaster for this. It's essentially where we invite a large DDoS to our website and ecosystem every time we release a major artist ticket or a concert. So if you think of you know, a Beyonce or somebody like that goes on sale, and then we make matters worse by taking limited amount of supply, and then we tell the world when it's going on sale, and then the market conditions of limited supply and demand mean that the face value of the tickets, there's room for arbitrage there, which means that we invite the entire planet worth of computers and humans to come and try to get tickets at once. So we literally, you know, light our systems on fire, and they scale from 0 to 100 in a matter of, you know, a minute or seconds. And it means that we stress out every component of our products and systems, right? They need to be able to scale quickly, efficiently, and all at once, which is not like most scaling needs. So it means that the things that we deploy need to be essentially, you know, enterprise bulletproof military grade, which provides an ever changing amount of technical things that we have to solve for.
Got it. Okay, and then I'd love to also just hear, like, on top of that, so you have the technology problem, you know, what does your competitive landscape look like now just as a business?
Yeah, so I would say this was equally as important as a driver for us to really start changing our business. You know, just like every other business out there, right? You either are disrupting yourself and changing every day to maintain your position in the market or to continue to grab market share, or you're quickly going out of business. I mean, that's just the state of reality, right? And for a company like Ticketmaster, we have a huge surface area of different business and products and segments that we're in, and being the market leader of all of them, you know, we're we are essentially under attack constantly by, everything from the two people in the garage to, large competitive companies looking to get into our space. So, it is a constant challenge for us as a company to stay nimble and stay quick, to be able to, maintain and grow our position in the market.
Got it. Okay, so with all that in mind, now I wanted to start diving into the actual, kind of the path here that you've been on over the last few years, as you've gone and kind of, reimagined, I guess, or rebuilt how you do all this. So kind of with all those challenges in mind, can you just tell us a little bit about, your approach to modernizing your infrastructure?
Yeah. So at the highest levels, right, you have to get conviction at all levels of the company, right? And the way we frame this to ourselves essentially is what we're really after, right, as any company is more revenue, more market share, right? And to get that, you need better products and better features, right? And then to get that, you really need to deliver products faster and iterate on products. And then for us, what we find was a limiting factor there is we needed our product delivery teams to be autonomous, right? To operate like small startups and not like a giant monolithic company. And so for us to really enable these smaller product teams to be truly autonomous and become little startups within the company, we needed to simplify our platform, right? The things have to be usable by these teams without needing, to reach out and talk to 20 different dev teams or our operations teams to get something done. So really for us, it was the conviction to simplify our platform that really started the whole thing off. And then
I was just going to say, in the past, I know you've talked about this as like kind of a self-disruption. Maybe you could go into that a little bit. What do you mean by that?
Yeah, so essentially, when you look at the market, right, there's companies who clearly are disruptors, and there's ones that are not. They're keeping going steady state as is, right, and maybe iterating just a little bit. So we went the approach where we wanted to completely disrupt ourselves so that we don't get disrupted or displaced by another company, right? So we intentionally, at the senior executive levels in the company, refer to it as we're rebooting our company. And we've made structural changes and investments along the way to really make that a reality and deal with, the short-term investment or any short-term pain that causes and discomfort, knowing that there's a larger strategic effort in really modernizing a company to be a modern software delivery product company. So we refer to it as we're going to be Uber and not Yellow Cab. No offense to Yellow Cab.
Yellow Cab is definitely trying to be Uber too. Okay, so kind of first it was the disruption, and then, could you talk through kind of how you started to get your teams to focus on the critical issues at hand?
Yeah, so the first order of business for us was, we went through what we'll call a lean transformation stage, and this was getting ourselves out of the water scrum fall mentality, or it was really to start breaking up our teams into cross-functional teams, and having them solve real business problems. You can almost think about it as like our two pizza team era. And really starting to break down the silos across the company. So we created tons and tons of teams, right? 65 of them at one point. I think we actually got over 100 teams at one point. And all these teams got really, really, really good at, building software and solving business problems with software. But they didn't really get much faster at delivering that software into the market, right? We sort of found that there's a big difference and there's a gap between I built the software and my new software is running in production and we're making money, right? There's a huge gap there. So it became like step one, right? We started to form these teams. And then that sort of led us to the next phase, if you will, was really moving into these autonomous delivery teams that are full stack. And, I'm sure everyone's heard the term full stack, and it's probably loaded with all kinds of connotations. But, for us, it meant we need these teams to be able to be completely autonomous and self-sufficient, meaning no tickets, and not to be confused with Ticketmaster tickets, but like Jira tickets or like work tickets, meaning like every time a team, submits a ticket for a piece of work to get done outside of their team, that's a failure pattern for us. That's an error in our system. That means something wasn't self-service, or we're missing the skill set to do it in the team, or there's just some piece of friction that we want to get rid of. So we really started focusing on creating the self-service tooling that we needed and the autonomous delivery team creation to essentially create what we're calling micro businesses. And these teams, they build it, they run it, they own it, they optimize it, they monetize it. They're for all intents and purposes like tiny micro companies within the company.
Got it. Okay. And as you went through this whole process, what did you and your teams learn?
Yeah, so basically what I describe it is that was kind of our DevOps phase, if you will. And every big company has been through the DevOps movement in some way, shape, or form, and it's really hard at scale and at a large company, and there's so much muscle memory that it challenges every aspect, from the technology to the cultural to just change management at scale is just hard. So all coming out of that, right, we got the ability to have these teams that were autonomous, but it didn't feel like there was enough. It felt like, okay, we're not moving as fast as we believe we can move. And when we started really looking at it, there's a few stats that stick out, right? We still had about 150 different ways to release products. Every team was autonomous, meaning that some of them had a really elegant way of delivering their software. Some of them had tarball moving around and gzipping and manual stuff and everything in between. So we know that wasn't optimal. We found out that about 30 to 50% of our development time was literally spent moving code around the system in all the different environments, deploying it, testing. Huge dollar amount waste at scale doing non-value activities. Right? We don't want people moving software around. We want the software to land in prod and start making money, right? Or start becoming a great feature people love. And then on the impact side of it, we were still having outages, and a lot of our outages, 50% of them were, the root cause was something that was preventable, right? It was a self-inflicted error because of, some complexity in our system, right? So really that gave us conviction again to continue the journey and make a business case that, hey, we're not done. DevOps is not the end. Like, we need to continue to invest in our technology platforms and modernizing our software stack.
Got it. Okay, and I guess now you mentioned kind of some of the stuff you wanted to modernize your infrastructure stack based on kind of all those lessons learned. Maybe you could just go into that a little bit in terms of, with this new insight, what are you doing about it?
Yeah, so essentially what we did was, we got conviction as a whole that we were going to go and start leveraging the public cloud and push everything into AWS. And the reason why we're doing this was we viewed that as our giant carbon filter for the company, right? It was the catalyst and the filter for us to take every product, every piece of software, and modernize it and mature it. And we built a whole maturity model around what does that actually look like, essentially to make these products cloud native. And it's the, knowing that you don't want to end up landing in a public cloud without building all of your ilities, right? Your monitorability, scalability, deployability, operability, all of your, things that make software run appropriately inside of a public cloud, we needed to handle. And so what we got out of it was, the concept was, what we're getting out of it is, it's the carbon filter. So when it lands on the other side, our software is nice and clean and easy to operate, right? Instant modernization. So we built a team around that and we went with the cloud enablement instead of cloud migration team. And basically the concept there was build all of the patterns and the tools and the scaffolding to then give the know-how to all of these distributed teams for them to do it themselves. Because we want those teams to own and operate their software. So we don't want a centralized team to do it for them, because you will never be able to hand it off, right? Then you'll always end up with the central ops team. So it was all about enablement and not about migration. So, and heavy around self-servicing. So we kicked that off. Essentially what we came up was we had 7 steps, quote unquote simple. Basically containerize your applications. We were already using CoreOS, so we just standardized it on using container Linux. We were, terraform your infrastructure. So, ensure that you're deploying everything via software and not deploying it via hand. Instrument everything. And so one of the sort of key declarations that we made was not allowing SSH or RDP into your containers once they land into their new landing zone in the public cloud. And really what that was it was a way to ensure that we have the maturity around the product to where it has the built-in telemetry and automation that it needs to be completely immutable, and it doesn't need people to log in to change stuff. And it's a hard one. Like that's a challenging one for most teams to do. But it's super key to make sure that you don't end up with things that needed to be hand edited or modified in prod. So then, using synthetic monitoring to understand our product health, all of our, obviously, a bunch of layers of security that you need to bake into your pipelines, and designing a shared nothing architecture. So no centralized NFS stores, no centralized config files that need access to, and essentially just building for high availability and no single point of failure, right? That was the goal. That was sort of the framework of what it takes to deploy through the carbon filter for us. So what we did was, we had all this ready. We had a bunch of tooling around it. We had the process and procedures. We had 1,000 pages of documentation ready to go. And we opened the floodgates, and we were saying, like, in our minds, right? It's like, next week we're going to be all in the public cloud, and all of our software is going to be modern. It's going to be fantastic, right? So it didn't quite go as planned, as you can probably imagine.
Yeah, this slide we have up, I think it's a good foreshadowing here. So tell us what happened.
Yeah, so we definitely took away some learnings, right? So some of the learnings were, we go into a public cloud, like Amazon has a rich set of APIs and primitives to use, right? And we have hundreds of developers across the company that we are, from all walks of life, all different skill sets, all different tech stacks, all different eras of software they're working on. And essentially what we're asking them to do is learn all of those APIs and those primitives and how to deploy infrastructure, right? And then we were using Terraform as our entry point, right? So then we're saying, not only do you need to learn all this new cloud stuff, you need to learn how to deploy all this new infrastructure. what's a load balancer, right? Now they have to deploy their own load balancer. And they have to not only figure out how to deploy resilient infrastructure for their software to run, they need to figure out how to write software inside of a new language, inside of Terraform, in order to deploy infrastructure. So that's a pretty steep learning curve for a vast workforce of people to pick up. And then one of the other things that was a huge learning curve on the next slide was, for me and for other executives around the company that care about money, Terraform became, I started looking at as Terraform is now our programmatic checkout page. It's add to cart, and then its deploy is checkout. And we've distributed the ability to check out across, 1,000+ people in a very distributed way, which makes buying stuff really easy, but accounting for it is a little bit of a challenge. So, and then, the one stat that I thought was pretty staggering is at the reInvent conference I was at, or that there's 65,000 different permutations within AWS to combine their service offerings to deploy something. So that means that there's probably around 64,999 ways to do it wrong or not optimal, right? Like there's always a price performance value ratio of deploying a workload. And if you do it by hand, you're definitely going to do it, not optimal. So if I sort of summarize all of those learnings, really what we had was, it was a huge learning curve for our workforce at large. It's very difficult to manage distributed systems at scale. We were kind of asking the wrong people to build and optimize the infrastructure. And then not only that, we were asking hundreds of the wrong people to take on that burden. And then we were baking purchase decisions into distributed code that lives in distributed software repos. And if I distill all that down, right, we were spending too much time writing software to deploy software instead of writing software to make money, right? So as a business, that's a problem.
I guess once you got to this point, where would you characterize your greatest sources of pain? There's a lot of different things you've learned. I'm curious, just what is the thing that's really keeping you up in the middle of the night when you get to this point?
It's really how to get a simpler model for managing tons and tons and tons of software that all needs to work together, and it needs to be supportable at an enterprise grade. And when it's at that level of autonomy and DIY, it's just not, right. It felt like it was the erector set that we built was too granular. It was built out of the tiny Legos, and those are easy to choke on, right? We needed to use the Duplos and the bigger Legos and make it a lot easier for everyone to build what they need and make it a little bit more standardized and operable.
Yeah, there were kind of two things. You initially said it was about application, just you have tons of different applications, and managing that was just a huge source of pain. And then essentially you're saying you want a higher degree of consistency, with the Lego analogy, right? You want less diversity in terms of how you deploy things. Is that kind of a fair characterization?
Yeah, and being able to manage and monitor, being able to just operate it with some centralized oversight for the areas where you would sort of traditionally think that you need some centralized skill sets. So it's a little impractical to think that you can have these full stack teams be really good at optimizing distributed systems and clusters and, understand the difference between every different version of compute offering. which one you get how do you do workload optimization at scale and do the math there, make smart buying decisions. Those types of things are really best centralized, where you can have subject matter experts handle it for the enterprise at large, instead of needing those skill sets inside of every team. It's just not practical.
This last little piece before we move forward, I'm curious on, how long were you in this phase where you were using kind of AWS and Terraform, and roughly how many people? And what I'm getting at is, how much time and money do you think you used in this first phase before you switched to Kubernetes?
I would say probably a year or so, and it all kinds of varying degrees of success. There's teams that really flourished and blossomed and had the right mix of skill sets, and also, to be fair, had the right software stack for it to be not as complex. And then there was some that just it was a real uphill battle, and led to fragmentation of some services are easily deployable and they live there, and some are back at home base and dealing with the crosstalk between the two ecosystems.
And I guess scope of people that were working in this year was about 50, 100, 10, just some idea of
hundreds.
How many folks you had?
Couple hundreds.
Okay, so if you had a couple hundred teams that their teams were, or a couple hundred people that their teams are responsible for producing Terraform scripts on AWS and kind of this whole automated checkout system.
Yeah.
Okay. All right. Now let's talk about how you tackled all this and why you chose Kubernetes.
Yeah. So good.
Oh, I was just gonna say, yeah. So I guess, why did Ticketmaster choose Kubernetes?
Yeah, so with all those learnings, right, it became clear to us that we need to abstract some of these complexities from the company, right? It's just that wasn't working well, and it was about the same time that we had been internally in our tech teams talking about container orchestration as a solution. And we didn't have enough conviction until about this point to say, we need to invest in it. This can help abstract some of these complexities and make it feel more like a supported company platform than a DIY kit. So we went out and did all of our due diligence investigation, looked at the playing field at that time, right? And it was just clear to us that Kubernetes was the winner there. Mostly because of the community and the support that we get from the community, and just the vibrancy of the Kubernetes community compared to the others, and the sort of it didn't have a hard commercial slant to it, and so we kicked the tires of it internally, did all the bake-offs that you would expect, right, and then what really sort of solidified Kubernetes for us is we solved a problem with it internally, and it was a problem that was plaguing our own tech ops team. And when you use something and it actually solves a problem, you have way more conviction for it than just reading slides or presentations or whatever, right? So essentially what we had was, we use OpenTSDB for our time series data at this point, and it's critical for us. We use it, for our telemetry into so many things. So it's our eyes and ears for real-time traffic and the tons and tons of analytics that we have on that traffic. So you imagine we're doing an on-sale, big-name artist is selling. You have things that are happening and decisions being made sub 1 minute granularity, like at the level of roll more shows or business decisions being made. So having these metrics available in these dashboards from these systems critical to us, and then we're sending tons and tons and tons of metrics, 500,000 metrics or more a second, and the thing would explode on us, right? Anyone who's done OpenTSDB or any of these time series databases at scale know the complexities of running them. And it was a struggle for us to scale up appropriately and not exploding. And the team used Kubernetes. They deployed it onto Kubernetes and used the self-healing and health checking features essentially out of the box of Kubernetes to essentially make it to where when it did explode, we didn't see it. So, for me personally, that meant that my angry peers and consumers of our products, my emails about, asking us, when is this going to be fixed and all that, went literally from like 10 a week to 0. And so it gave us a lot of conviction that, hey, this works. Like this is, in real life, has made our OpenTSDB problem fade into the background. And, I literally forget we have it. Like it just runs now, right? And if it has a problem, it self-heals. So that was, I think any advice I could give is solve a problem with a piece of software or a technology, and quickly the adoption and the desire for it across the company grows.
Okay, now let's talk about your path to adopt Kubernetes. It sounds like you had a bake-off, you solved a problem, now you want to make it real. What happened next?
Yeah, so the first step for us was we assembled a team. We knew we needed a team to drive this forward. So we built a team internally, called them the Kubernauts. We created an amazing logo with stickers. So that's legit for us. We knew it was a real team when we got the logo. And really, we set them up with a mission of like, these were 6 folks that this is their full-time gig now, figure out Kubernetes, figure out how to be a high-performance cluster ops team for the company. And, even in the early stages of Kubernetes at that point, solve problems that may not have been solved, in the upstream yet, that level of team. So we quickly learned that we needed help, right? So we ended up, engaging with the community, fairly constantly and reaching out to all the different areas within the community. Spent time with you, Alex, and your team at CoreOS, along with, others, and Kelsey Hightower and team, and we just really were leveraging the learnings and trying to get situational awareness across the board of how do you build this at scale and for an enterprise where you have traditional enterprise expectations and operations around it. We joined the SIGs, and the SIGs are amazing source of information and help from like-minded folks. And then we ultimately ended up joining as an end user on the CNCF, which has been fantastic to be a legitimate part of the community. And really what we were looking for is, how do we build, what is the roadmap to build a enterprise-grade cluster? How do we operationalize it? How do we make it enterprise-ready with all the HA features? How do we make it consumable by our apps and our app teams? What does an organizational chart look like around this, right? And at that time, there wasn't a lot of answers, right? There was a lot of questions.
Yeah, and I'm curious just the amount of time that went between when you decided Kubernetes, you got your team formed, and you decided to partner with someone. Like this process of talking to CoreOS and Kelsey and others, was that right out the gate, or did you do it by yourself for a while?
We probably spent 3 to 6 months, I would say, really hardcore. I would say like majority of our mind share was in this space. So we weren't dabbling. We were, flying places, attending wherever we could go, conferences. We were immersing our teams in making this happen. But I would say it's probably still 3 to 6 months of calendar time.
Got it. Okay. And so as you look to partner, why did you decide to turn to working with experts? At what point, I guess?
Yeah. So really, so we had assembled our cluster, like we had things working, and the thing for me, the biggest thing was the team didn't have confidence to go full production deployment. Meaning, when we're dealing with high volume traffic in very sort of stressful, high profile, real-time situations like an on sale or something like that, we have to have absolute experts, right? We have to have somebody who, if something goes wrong, can quickly go from looking at monitors to kernel level, like what happened, like in seconds. And we knew we just don't have that experience on the team, Kubernetes, and to get that experience is a fairly sizable investment and a long road. So we decided it makes more sense for us to partner with a company like CoreOS and use an enterprise supported stack like Tectonic, so that we have enterprise grade confidence for operations around it, right? And that we are confident that CoreOS is putting the right software stack together. They are building out the right reference architectures, so we don't have to worry about does this network stack go with this network stack, or this thing go with that thing, right? It's better just to have, hey, this is a well thought together machine that's commercially available, instead of having to wonder if we have the right solution, right? And it really just gave us the confidence to go production. We have live support, and the other things that are sort of, I would say, cherry on the top for us is the ethos around the automatic updates and the self-hosted stuff, along with the not having to worry that our software is going to maintain itself, right? Like, nobody loves patching, and putting together a rigorous patching schedule sounds like pulling out my hair. So having that just inherently baked in is an operational win.
And let's just talk about pain again. I like talking about pain. So we talked about the pain that Kubernetes solves for you, but I mean, I see these things on the list. If you think about the pain in terms of what's keeping you up at night, or just, gosh, I really have to get that fixed right away, what did you see Tectonic solving for you in that context?
Yeah, so at the current time, we were sort of we were solving things that hadn't been solved yet. So, for instance, deploying Kubernetes at scale inside of AWS and handling something like the ingress controllers, right? And the last thing we wanted to do was build our own stuff that was not going to make it to the community or not go upstream. And I didn't want to sponsor the Ticketmaster software development, and operational team. So, working with the CoreOS team on helping us solve some of these problems, right? The CoreOS engineers, integrated into our team, helping us build things like the ALB ingress controller, right? That now we have the confidence to run, ingress at scale inside of AWS using all the ALB features and all that. So it's solving these complicated technical problems that you don't get just out of, or we don't have the time to wait for it to come out of upstream, but having the confidence in a partner that has the ability to actually help us produce it and make it part of the vanilla upstream. That one, the billing one is a good one that sticks out in my mind. Having our ability to influence roadmaps, right, and working with the product team at CoreOS, sort of say, hey, there's an enterprise challenge here, right? Like for me, I essentially am a cloud provider for the company, and Kubernetes is another cloud offering. So if I have tens of thousands of unique pieces of workloads that are essentially racking up a bill on the back end, I need to have granular level billing abilities and break down by per per minute usages and really tie that into a company level chargeback. It has to be thoughtful and thorough, and it's just an example of something that enterprises need, whereas non-enterprise companies could probably care less, and whatever comes out of the box is good enough. But it's a focus on what big companies actually need, and not having to build it ourselves or put together some sort of DIY solution around it.
Right. So when you think Ticketmaster versus Tectonic, two different distributions, Ticketmaster being the one that you would build yourself, I'm curious, in terms of when we talk about the problems that just choosing Tectonic solves over building it yourself. I mean, outside of just like technically assembling it and doing it correctly, which I would anticipate as like a hiring problem more than anything. What other problems would lead you to choose a packaged kind of product versus assembling it yourself?
Yeah, I think that the constant care and feeding of it is important, right? So the constant updating and keeping up with the market conditions of so essentially, we want to make sure that our team is focused on driving Ticketmaster forward, and the more we can get out of Kubernetes, or having someone packagize Kubernetes and continuing to make it modern, day in and day out, and make it more, keep expanding on it where we don't have to, it's a huge win for us. Along with, continuing to ensure that it's using the, I would say, best of breed underlying technologies as part of its package, so that we're not constantly, out having to evaluate all of the subsystems within, the Kubernetes ecosystem.
I guess why does that matter?
It's a good question. So I think it keeps going back to me to the point where, in order to do that at a sort of professional grade, you have to invest in it, and you have to staff up a team or a section of the company that focuses on that and is the expert at it. And that's not where our core expertise is, right? So I think relying on a partner is definitely more preferred, right? That way we're not spending all of our mind share on, building a competing product where there's companies that are already really good at building those products. Does that make sense?
Yeah, so just to regurgitate a little bit, you're saying you have to get this product deployed somehow. So you have a choice to essentially build it yourself using open source, or to buy a solution. And then, again, it's about who can do it most cost effective and faster. And that's kind of the end decision. Is that, again, a fair characterization?
Yeah. Cost effective, faster, who can do it right, and right. Sort of at the sort of large scale enterprise level, that matters, and there's a certain safety in that, and a comfort level, right? Knowing that CoreOS has an entire workforce behind focusing on one product, whereas Ticketmaster has an entire workforce focused on thousands of products that are mostly ticketing.
Right, your original problem that you're trying to solve. Yeah. Okay, so let's talk a little bit about the outcomes of all of this. So what happened once, as now we're kind of rolling with the partnership and everything, where are you at now?
Yeah. So, one of the glaring stats that I like to talk about, right, is we have one team one of our large teams that is building the next generation of our website, right? And for us, that's a huge undertaking, right? This is a massively complicated website ecosystem with hundreds or thousands of services and all that inside of it. It's a pretty modern system. It's a couple years in the making, but it was when it was running in just the Terraform stack, not Kubernetes. It was modern, immutable, containerized in Docker, in AWS. It still took that's 20 minutes or so to do a deployment, and frequently had problems. Something would break along the way. Oh, this configuration's not right, or it's missing something. So that kind of lower confidence around it. And when you have hundreds of people working on a product like that, day in and day out, trying to move the ball forward in 100 different ways, that adds up. That matters. So we moved that whole system to run in Tectonic, and what we saw was the deployment time went down to 60 seconds or less, and the real value there was, and the confidence went up. Like it just works every time, right? There's no occurrence where it's like it breaks downstream some pipeline piece. So the combination of being able to deploy very fast and have extreme confidence across all of these teams, it unlocked the ability to do daily delivery and the culture around daily delivery. And what that means for us is, deployments are a non-issue for these teams now. They don't talk about it. They don't obsess about moving stuff around. And for any sizable development teams, how much time is talked about, daily stand up for a team. And at some point, somebody's going to say like, yeah, pushing it to dev or pushing it to this environment, going to do some testing. And there's some talk and chatter around the logistics of moving software around. Now that chatter's gone. And the focus is on what are you delivering that day, business outcome. And the team talks about, I'm going to deploy X and I'm expecting these results. And there's a stand-up at the end of the day where they show their results, right? So we're talking about changing the culture from we're delivering business features, enhancements, improvements, revenue generating something, and then looking at the actual graph of results at the end of the day. Like that's the new culture and the expectation that the teams have of each other. And you can only get there when you remove all the friction, right? Or else it turns into talking about the system or the deployment or the error du jour. So it really unlocked that culture for us. So pretty exciting.
Got it. Awesome. And maybe we have some great questions rolling in right now, so I want to get to those in our last few minutes. But if we could just do a quick summary, kind of overall of our partnership and kind of what we've accomplished so far together.
Cool. Yeah. So I mean, at the big picture, right? We're migrating vast majority of our apps and products onto Tectonic. We have confidence in the product, the relationship, and the benefits that it gives us overall. We see true business value out of going this direction. Having a true partnership where we're influencing the roadmap of Tectonic and bringing enterprise features and like our complex needs as a large enterprise into the forefront of the Kubernetes feature roadmap is fantastic. Continuing to solve joint problems together, right? Every month we're going to have a new problem of something that's technology problem or scale problem, and having a team that can actually help us code up solutions and architect them is fantastic, and really just helping fostering the enterprise Kubernetes community, right? What we want nothing more than anything is to have a bunch of companies like us where we can have a true community of like-minded engineers, teams, leaders who are contributing in this space so that our ecosystem blossoms and makes the whole Kubernetes landscape better.
Got it. All right, well, thank you. I wanted to just jump into some questions now. We've had some pop up. So we'll start with this first question. I'm just going to read directly. I often hold Ticketmaster as having a system of record where consistency is key. With this architecture, how do you handle your database tier?
Yeah, so I agree, because consistency is key. Going public cloud, right? We will use data services that a public cloud offers, right? Like, and where it makes sense, we'll put those things into containers and run them, inside of a Kubernetes ecosystem. But we definitely are careful at those levels where if it's an appropriate workload to run in a distributed ecosystem like that, we'll run it. Where it's not, we won't force it. So does that make sense?
Right. That makes sense. We've talked a little bit about wanting to bring those services into Kubernetes itself or inside of Tectonic. Maybe you could elaborate on that, kind of your ideal way that you'd like to do it.
Yeah, no, the concept of operators is definitely exciting, and I think the future's bright for that. We're effectively running a hybrid cloud, right? Like every enterprise out there, right? It's everyone probably has a public cloud footprint as well as data centers and on-prem and some mix of thereof. Having the operator concept where we can treat operating a system like MySQL or something like that as a cloud service that is baked into software and configuration within the Tectonic cluster itself. Sorry, I'm losing my voice. is really appealing and exciting to us to be able to offer essentially, our own hosted services that look like cloud services on top of Kubernetes without having to staff them up with, massive teams to operate them at a high degree of competency, right? So that's one area where we're definitely exploring, and we probably won't start at the data layer there. We'll probably start at the data sciences layer maybe, or like the Kafka queuing layer or something in there where providing on-prem and off-prem access into those services that are higher level is very appealing for us.
Right. Okay. And I guess one last question here, as we're just about out of time. This is a bit of a technical one too. Do you have any thoughts on just like the whole pipeline from where your teams are actually building their containers and whatnot to getting it running on Kubernetes? Like, what happens before the workload actually goes out onto the Tectonic cluster?
Yeah, it's definitely an area of continual evolvement, but essentially we're using Helm and Helm charts, and trying to make simple interfaces for developers to consume. Like, give us a couple pieces of YAML somewhere and merge it into a standardized template of a Helm chart and kick that into our GitLab CI pipeline, and it will make it to the cluster of your choice, essentially, right? That's kind of the big picture flow. We are working, on some things that would help us greatly. We have a huge Java workforce. We use basically every tech stack, but we have a large Java footprint, and we're actually working with the CoreOS team on some of the native integration into Java, right? Where if you could imagine deploying straight Java all the way through the pipeline, it would be way more intuitive for our development workforce than having them go out and create another piece of configuration that they have to manage.
Got it. Okay. All right, well, that wraps up our hour together. Justin, I just want to say thank you so much again for all your continued support and partnership, and for your time today. And for those watching, if you're interested in using Tectonic and getting started, we have Sandbox. You can be running in less than 10 minutes on your laptop. And then we have a fully published kind of case study about Ticketmaster on our resources site on the website for follow-up. So Justin, once again, thank you so much for your time and partnership, and for everybody that joined us remotely, thank you for watching. Have a great day, everybody.
All right, thank you very much. Talk to you later.